Hi all, my name is Vishnu Teja. My roll number is 24011A0534. I am from CSC Regular. Today I am here to explain about construction of a transformer. So, first of all, what is a transformer? A transformer is an electrical device that does either increasing stepping up or reducing stepping down the voltage without changing the frequency of AC power. So, why are transformers important? Transformers play a crucial role in the efficient and safe transmission of electrical power. You can see the everyday uses of transformer in the picture. Now, coming into the construction types, there are two types of construction type of a transformer. First one is core type, second one is shell type. A core type transformer is a type of transformer where the windings are wound around the limbs of a magnetic core. You can see in the picture the windings are wound around the limbs of the magnetic core of a transformer. This is the primary winding and this one is the secondary winding. And coming to shell type, a shell type transformer is a transformer where the windings are placed inside the core forming a shell around them. You can see the shell type transformer in a picture. This is the main central limb and the winding is wound around it, and the flux is generated in both the primary and secondary windings. Coming to the construction of a core type transformer. Core is composed of two vertical limbs. You can see that these are two vertical limbs and two horizontal yokes. These are the yokes. Core is made up of silicon steel sheets to minimize eddy current losses. Both primary and secondary windings are wound on the limbs of the core. You can see that in the picture that primary and secondary windings are attached to the limbs of the transformer. The windings are usually cylindrical in shape, so that the flux is generated in both primary and secondary winding. Coming to advantages and disadvantages of core type transformer. First, advantages of core type transformer are they are easier in maintenance. The cylindrical windings allow for better heat dissipation, well suited for high voltage applications due to effective insulation between the windings. Coming to the disadvantages, these are lower efficiency when compared to shell type transformers. Leakage of flux is more and power transfer capability is less. More amount of copper is required for windings. Construction of a shell type transformer. Core is composed of one central limb and two outer limbs. This is the central limb and these are the two outer limbs. Laminated silicon sheets are used to minimize eddy current losses. Both primary and secondary windings are wound on the central limb. The windings are often divided into sections to reduce leakage of the flux. Coming to the advantages and disadvantages of shell type transformer. First, advantages are the winding arrangement reduces leakage of flux, leading to higher efficiency. These have better cooling system than core type transformer. Lower leakage reactance, well suited for low voltage. Less amount of copper is required. Coming to the disadvantage of shell type transformer, it has complex construction, higher manufacturing costs because it requires more amount of insulating material. Coming to the constructional features of transformer winding. Copper is the most commonly used material for transformer windings due to its excellent electrical conductivity and it has low resistivity. It ensures minimal power loss during the transfer of electrical energy. Another material used for transformer winding is aluminum. Copper windings are used in power transmission transformer and aluminum windings are used in distribution transformer. Based on windings, there are two types of windings. First one is primary winding and another is secondary winding. Coming to primary winding, it receives the input electrical power. It is made up of copper wire. The number of turns determines the input voltage level. Coming to secondary winding, it delivers the output electrical power. It is also made up of copper wires. The number of turns determines the output level voltage. Coming to the working principle of a transformer, an alternating current is applied to the primary winding. The current in the primary winding creates a changing magnetic field in the core. This magnetic field induces an EMF in the secondary winding. By that, the current is generated in the secondary winding. The ratio of the number of turns in the primary and secondary windings determines the voltage transformation ratio. Coming to the conclusion of this PPT, the transformer operates on the principle of electromagnetic induction. It can either step up or step down voltage without changing the frequency. So it is called a constant frequency device. Transformers are crucial for efficient power transmission and distribution without any losses. Thank you.